So in our last few videos we've been talking about sampling to find the mean of a population or to test a hypothesis or an assumption about the mean of a population. We're dealing with values. But what if instead of trying to find the mean value, what you're actually trying to find is the prevalence of a trait or the proportion of people who feel a certain way, like an A, basically a proportion of A versus B. In other words, we're dealing with percentages. We might say we want to figure out what the error rate is in our products. And that's a percentage. It might be 1% or 2%. Hopefully even lower than that. The error rate in our products would be a proportion sampling. So let's look at an example, and you'll see what I'm talking about. Let's say you're a political interest group, and there's a politician who claims that 85% of Americans favor mandatory background checks on the purchase of firearms online and at gun shows. So the claim is 85% of Americans favor these background checks. And you would like to conduct a sample to test that politician's claim. So you could run a survey, but what do you do with the results? We're not dealing with a numerical value here, we're dealing with proportions. And so normally you would use, Z equals X minus, you use X bar for your sample minus U divided by standard deviation, but that's sort of the old way. That's if you're dealing with values. What do you do if you're dealing with proportions? Well, instead of X bar, we would use which is the measured average of our population. We're going to get the measured average of our sample. That would be X bar. We're going to get the measured proportion of our sample. So we're just going to survey 100 people, say, and figure out, okay, what's the we would ask 100 people, whether they support these mandatory background checks, and the number that say yes out of 100 is going to be our, divide by our total sample size, and we're going to get our proportion that support these measures. That's pretty straightforward. Our expected value is P. We're actually testing P being in this case the politician's claim, which is 0.85. But then here's the trick. Our standard deviation for our sample proportion is going to be equal to the square root of P times 1 minus P all over N. Oops. That is the standard deviation. Again, the standard deviation of our sample is sort of the thing that changes. We saw that when we were talking about just standard sampling. Standard deviation of a sample is different than the standard deviation of an individual result from the population. Standard deviation of a sample proportion is different as well. And so what we use to calculate the standard deviation of the sample proportion is P, which is our expected value, or it could be our hypothesis that we're testing, the proportional hypothesis we're testing, times 1 minus P divided by N, N being our sample size. So let's use this, and let's actually extend our example here. So let's say in that sample of 100 people, we asked them, do you favor these mandatory background checks on purchases of firearms online and at gun shows? And 83 out of 100 support. 83 out of 100 said, yes, we support this. Is that enough? Is that far away from our expectation, which was, or from the politician's claim, which was 85% support, to warrant us calling that politician out and saying, you're a liar? Well, let's work this out. 83 out of 100, that equals 83%. So this is our sample proportion, right? 83%. And our expected value is P. That would be 85%. So that's what we're testing. And our standard deviation of our proportion is going to be equal to the square root of 0.85 times 1 minus 0.85, which is going to be equal to 0.15. I'm going to use the standard X for multiplication there. Looks a little bit better. Divided by 100. And if you do that calculation, what I got anyways was 0.0357. And so now we just need to plug this all in. We're substituting in for x bar with our sample proportion, u is p is substituting in for u, and the standard deviation of our proportion is going to be subbed in for the standard deviation of our population. So we use z equals p hat minus p divided by standard deviation of our proportion, and that's going to be equivalent to, in this case, 0.83 minus 0.85 divided by 0.0357. All right, and my math gives me here negative 0.56. And that's our z value, negative 0.56. Notice we're doing everything the same here. The only trick here was recognizing that we're dealing with a proportion and then using this, this equation right here to calculate the proportion. So I'm going to circle this because I want you guys to remember this. And let's go ahead to our z table, because we've got a z value. Now we can use our z table. I'm looking up negative 0.56. And that gives me a cumulative probability of 28.77%. Okay, I just want to, let's get back and remember what this all means. So I'm going to draw my normal distribution. I always encourage you guys to draw your normal distributions. It's just helpful. I've got lots of practice doing it now. All right, our assumption here, the hypothesis was that 85% support. That's the thing that we're trying to test. Do 85% support. And we were using our sample. Let's actually, I just want to give myself a little bit more space. Our observed value was 0.83 in our sample of 100. And using our sample proportion, and notice here, same deal, the larger the sample size, the lower the standard deviation of the sample proportion. This equated to negative 0.56 z. And when we looked negative 0.56 z, or a z value of negative 0.56 in our z table, we got 28.77%. And let's remember that what were we testing? We were just testing this claim that the politician said 85% support gun control legislation, the background checks. We weren't testing whether that was too high specifically or too low, just testing whether it was accurate. And we need to have enough evidence to reject this claim. So what we're actually going to test also, so it's not just, we ended up with a value that was lower than the 85% claim, but what we really need to include is what's the probability that we would have ended up this far away from the mean? If the mean were true, what's the probability that we would have ended up this many standard deviations away from the mean in our sample proportion using a sample size of 100? Well, so we have to test in either direction, because we're just saying, what's the chance that it would end up this many standard deviations away? So it's 0.56 standard deviations to the left or 0.56 standard deviations to the right. So we have to add these two together. This is also going to be 28.77% because the normal distribution is symmetrical. And that's also going to, if we add those two together, can't do it in my head. 28.77, that's going to, if we add these two together, we get 57.54. And actually that means that this part in the middle, the chance that we would end up at that many standard deviations or less is actually pretty small. It's actually pretty close to the mean. This is 42.46%. So what does that all mean? It means that it's entirely likely that we would end up this many standard deviations away from the mean. This is kind of like our last example. We end up, you really, in order to reject a claim, in order to be able to say, I'm pretty sure you are wrong, or I'm pretty sure that we need to reject our null hypothesis, our original hypothesis, which is that the number of people who support is 85%, this value in the middle would need to be like 95%. In other words, we would need to be able to say, you know, I'm 95% sure that you are not going to get an observation that is that many standard deviations away from the mean. How sure are we that this is wrong? Oh, we're about 42.46% sure, which is nothing. It means nothing. You know, essentially, this is actually pretty good evidence that the politician is right. So really, what it says is, you know, for us to reject a claim, we usually are going to have some sort of a confidence that we require to be able to reject a claim, and usually it's, you know, 95% is pretty standard. But oftentimes in research, you'll want to be like 99% sure before you're ready to reject a claim or reject a hypothesis, a null hypothesis. You know, I think that's pretty standard, like in things like medicine. So you would want to see something many more standard deviations away from the mean. In other words, these outlying parts are going to add up to 1% or less. So in this case, you know, we really can't reject the politician's claim. The main thing I want you to realize here is when you're dealing with proportions, you're really just following the exact same procedures. The standard deviation of your proportion sample is going to be equal to this, where P is sort of the value that you're testing. It could be the proportion from your population or your null hypothesis here. All right, we will look at more examples of proportional sampling later on. We're going to do a lot of examples of hypothesis testing, and you'll see some proportional samples. So if you didn't quite get it this time, there will be more opportunities later on.